Hey everybody, Sean Tierney here from the Automation Blog and School. And in this episode of the Automation Podcast, I meet up with Nehemiah McIntyre from HBK to talk all about signal conditioners, including the advanced features of their smart signal conditioners.
Nehemiah, thank you for coming on the Automation Podcast to talk to us all about signal conditioners. Really appreciate you taking time out of your busy schedule to come on the show. But before we get started, and the audience may notice, I'm actually in the studio, not in my actual office with the fake background. I'm actually physically here in the studio. So if something goes wrong, please bear with us. In any case, Nehemiah, before you jump into your presentation to tell us all about these products, could you first maybe spend 30 seconds telling us about yourself?
Yeah, of course, Sean. My privilege to be here. My pleasure, certainly. My name is Nehemiah McIntyre. I have been an application engineer with HBK for the past 2 years. Started in the summer of 2020. I have my undergraduate degree is a biomedical engineering degree from Michigan Tech, and then my graduate degree, my master's, was in kinesiology as well from Michigan Tech. In general, I'm a big fan of photography, music, and dogs, and not just my dog, any dog. I love all dogs. So
Oh, that's awesome. So, with that said, I'm really interested. I know signal conditioners are very important. They're needed and they're critical pieces of certain applications. So I'm looking forward to learning more about what you guys offer to our market.
yeah, of course. So on that line of signal conditioners, just to give a brief overview of what I'm going to talk about today. One, we're going to address probably the big elephant in the room. In case you're unfamiliar with it, or this is something you've heard about, haven't really incorporated, I really want to touch base on what is a signal conditioner, and the natural follow-up question to that is, why do I need one? So once we have an idea of where these fit into the market space, where these fit into your measurement task, we'll dive into sort of the products that we offer at HBK, what we would call our smart signal conditioners. Of course, we're going to speak about the advantages of that, and then we'll wrap up with talking about how you can integrate one of these either into a new process or maybe even retrofit this into an existing process. So to start off, again, that big question: what is a signal conditioner? This is something that you're going to see a lot of confusion about maybe in the marketplace. People are using a lot of the same or a lot of different terms to talk about the same types of products. In general, the most broad definition I have for a signal conditioner is a device that prepares a signal for collection or processing somewhere else. It's sort of inherent to the name, signal conditioner. Sometimes you might hear this called an amplifier, right? Amplifier might be a little antiquated. It's tied more to these analog electronics where you have a really small signal coming in and you want to blow that signal up on the other end here. But an amplifier really doesn't encompass everything that a signal conditioner can do. A signal conditioner might also provide some sort of filtering. It provides that scaling, that amplification, of course. But you also might have some sort of a zero adjustment. Whether you're taking off a static sort of a tare value, or whether you're not exactly centered around zero in the case of like a 4 to 20 milliamp signal. So those can all be taken care of by a signal conditioner. Now, when you have a signal conditioner is really only part of your measurement chain here, right? You presumably have some sort of sensor. That sensor feeds into a signal conditioner, and then that signal conditioner gives you an output to your PLC, maybe your data recorder. All three of these elements here give you what would be called maybe a data acquisition chain, or your DAC. So all of these elements come together, they work together to give you that final measurement here. Now, if you're not very familiar with you know some specialized types of sensors, things like strain gauge transducers, you might be asking yourself, well, why can't I take my sensor, plug it straight into my PLC or plug it straight into my data recorder. And there's a few reasons why you may not be able to do that. So some transducers give really, really tiny outputs. Think about maybe a K-type thermocouple, right? You've got a 400 degrees or 1400 degrees Celsius range, and you might have a 60 millivolt swing. That's a pretty small resolution there. As I mentioned, strain gauge sensors. If you have a full bridge load cell, something like that, you might, under sort of the best case scenario, have a 20 millivolt output at full scale. 20 millivolts, a very small, very small voltage to be measuring with maybe a plus or minus 10 volt input on your PLC, right? You're talking about a very small percentage of that measurement range. Transducers might also need some sort of power. The term we would normally use, again, HBK, we're normally talking about strain gauge based transducers. We might call that excitation. Now your PLC may or may not offer this excitation, but whether it does or not, it's more a question about the quality of this excitation than its sheer availability, right? Anybody, you might have a 5 volt controls power source, 10 volt in your control cabinet. Plugging that into your excitation of your load cell probably isn't the best idea, because strain gauge sensors operate on this idea of a ratiometric output, where the value of the output is directly related to the value of the input. Most of the time when you look at strain gauge sensors, you'll see the output being listed as millivolt per volt. It's a unitless quantity, doesn't make a whole lot of sense until you dive into what these two elements really are. So we have our millivolts of output. I mentioned earlier, a strain gauge sensor might have 20 millivolts at full scale, divided by our voltage input, so our excitation voltage. In my example of 20 millivolt output, most HBK transducers have a datasheet sensitivity of 2 millivolt per volt, meaning that if you excite with 10 volts, you will get 20 millivolts out. That being said, you have to be very confident in the fact that you are feeding this exactly 10 volts. Because if you're feeding it 10.1 volts, 10.2 volts, if it's not a highly regulated voltage source, your output could be greater, could be smaller than what you're actually anticipating. Now you have greater uncertainties, and you're not exactly sure of what you're measuring here.
And to manage that in the PLC would be a nightmare, because you'd have to bring in the voltage and to actually run this formula inside the PLC. So if you have a voltage output for this to your strain gauge that is going to maintain 10 volts precisely, right? Or whatever the voltage is, then you don't even have to worry about that. You know that the power supply is taken care of, and it's just going to be reliable.
Yeah, certainly. And the beauty of something like a millivolt per volt, quote unquote unit, is that it's the same irregardless of your excitation. So if you have a signal conditioner that gives 1 volt excitation or 2.5 volt excitation or 5 volt excitation, because your transducer is being described in millivolts per volt, it's always normalized. So irregardless of that magnitude of excitation, you're always getting the same ratiometric output, which makes it pretty convenient when you're talking about this. Means you don't have to always ask, what was the excitation voltage, and do that mental math. Go ahead.
No, I don't want to steal your thunder here, but I wanted to kind of throw out some others too. So transducers, we totally get it, especially with what HBK does. But there's other places too. It could be that you need to run an analog. I mean, the amplifier situation where you got to run an analog much longer than you would normally want to, or you may have to interface with an existing piece of equipment, that typically when you build a new, everything's going to be 4 to 20, everybody's happy. But what if you have to interface with a new piece of equipment? It can be in many cases, a lot less expensive to get a signal conditioner for that one channel than to buy a whole nother analog card for your PLC that supports that range. So lots of different places where you might need a signal conditioner. I mean, and strain gauges being a perfect example, but there's a lot of other ones too. I mean, I think thermocouples were also a great example as well. But it's like one of those tools in your toolbox you need to be aware of and have access to for when you need it, And
Yeah.
a lot of times it's when you're doing a retrofit on an existing system, but it can sometimes be needed in brand new systems as well.
Yeah, certainly so. We will have a link down in the show notes to a technical white paper we have that is sort of 3 big errors in signal conditioning that'll directly go along with these ideas of why this is necessary, why in some applications it's not something you'll want to leave out of your measurement chain. So this sort of now that we have a firm understanding of a signal conditioner, today's presentation is more so about the smart signal conditioners that HBK offers. So to introduce or to sort of preface this idea, I want to start with an analogy, right? One that we'll all be really familiar with. So, back in the late 90s, early 2000s, we had phones, not smartphones like we have now. We just had phones, right? And these phones they were just about phones, right? They could call someone. A little later on, maybe you were able to text. If you were lucky, you might be able to play a really simple game on a phone, but that was it. It was no thrills, had really straightforward basic functionality. But nowadays, now 20 some years later, our phones are so much more, right? We still have those original abilities. You can still pick up your smartphone and call someone, but it's also a camera. You have utilities like calculators and navigation and calendars. You have interconnectivity with advanced networks like 5G connections. Signal conditioners have sort of undergone this same type of transformation, and I'll show that here. So back in 1998, when you might have had that Nokia phone, HBM then was selling this device called the Clip. The Clip was a series of signal conditioners that didn't really have a whole lot of frills, right? They took in each device took in a certain type of input. This one here was for bridge transducers. They were adjusted with potentiometers. Every time you needed to make a change, you'd have to send your electrician out. He'd twist down some screws, and you'd be good to go. And it was really just sort of a fancy multimeter, right? It was just measuring some raw voltage at the bridge, and that was it. But nowadays we have, these smart signal conditioners that can offer so much more than the old devices. You'll notice this picture here is of the HBK ClipX device, which is what the rest of today's presentation will be focused on. The ClipX is the natural predecessor to the Clip device over here on the left, and it can do everything that those old school signal conditioners could do, plus more. So not only do you have the ability to accept multiple different types of inputs, you have smart sensor identification with something like TEDS. You have interconnectivity to your industrial Ethernet buses, your Profinet, your EtherCAT. You have advanced device diagnostics that can always be reporting different statuses of your measurement chain. You've got internal calculations. You've got a digital configuration interface, right? No more potentiometers, no more dip switches. Much easier to configure than those older devices. To introduce this ClipX device here, I just want to give you a brief overview of it here. We will have a link down in the show notes to sort of a products page on HBM's website for the ClipX device. But in general, it is a single channel amplifier. It offers DC or carrier frequency excitation for your strain gauge transducers. That carrier frequency is 1.2 kilohertz, so you get about 300 hertz of bandwidth, and carrier frequency is inherently more noise immune. But I don't want to dive too much into sort of strain gauge technologies today. It has a 32-bit analog to digital converter, and it has that integrated sensor supply of 5 volts. Again, this is that regulated 5 volts that you can have a lot of faith in when you're plugging your strain gauge transducers into it. These ClipX devices have an internal sample rate of 19.2 kilosamples a second, so that's a pretty high sample rate there, giving you a bandwidth, in the time domain of somewhere around 3.8 kilohertz. So a lot of signal dynamics being measured with this one pretty small device. It does come in 3 different configurations. We have our standard BM40. This is our sort of our base measurement module. We have our BM40IE, which has those industrial Ethernet connections. So your EtherCAT, Profibus, Ethernet IP. And then we have our BM40PB, which has Profibus with, I think it's that DB9 connector that you'd normally see there. These are all DIN rail mountable devices. See the dimensions here in millimeters. They're somewhere around 4 inches square, and they're very thin. Really easy to fit a lot of these on your DIN rail and sneak them into places where space might be tight. So now that we have this idea of a signal conditioner, and probably more importantly a smart signal conditioner, sort of another question presents itself. That is, why do I need this smart signal conditioner now? What does this offer me? Well, if you're in automation, or if you're in these industrial electronic fields, then you're probably familiar with this term Industry 4.0. If you're not too familiar with it, in the show notes there will be a technical paper from HBM that sort of describes Industry 4.0, where it's coming from, gives a little bit of history around the term, but sort of the 10,000 foot view of it right now is that it. In industry, we're starting to see this trend, sort of this 4th industrial revolution, as it were, where we're not looking for machines that operate independently of one another and automate tasks. What we need now, or what is really beneficial for us, is to have these interconnected systems that are able to share data, not just with other machines at their level, but they're able to feed information up, maybe through OPC UA, put this data into the cloud where it can be accessed from multiple different locations. You don't have to be at the factory to see this. You don't have to be out on the floor to see this. You can, with sort of a cloud-based solution here, you can see this data from anywhere, and it's probably not as important the question of where you can access this data. The more important part is who can access this data, right? So all of the stakeholders, all the groups that would care about seeing this data are able to see it from this one centralized location. Your manufacturing groups, right? Your storage and logistics. So how much yield do you have? How many products do you have? Where are we going to store all that? Your groups that might be doing analytics. So how effective is the process? What is our yield rate? Can we tune this? Can we change things to make this a little bit better? But maybe most importantly of all, you have the opportunity to share this data with your service and support group. This becomes really important when we're talking about doing preventative maintenance. So with this data available for monitoring, your service and support group can look into this, see the performance of the machines, know when things might be decreasing in performance, might be able to look at some metrics that are indicative of requiring maintenance. Do that maintenance in a scheduled, prescriptive way. to make sure that you're not having unexpected downtimes or prolonged downtimes. This is, of course, important to save, to minimize the time of or the duration of these downtimes. But of course, being able to minimize these disruptions or plan around these scheduled preventative maintenance tasks is also going to save end users a lot of money. Another element of Industry 4.0 that the smart signal conditioner like the ClipX fulfills is this idea of edge computing, right? This is another buzzword that gets thrown around in this space all the time. More or less means we're shifting the smarts, we're shifting the determination, we're shifting the use of the data as close to the measurement as we can. And that's really what the ClipX is intended to do. I mentioned that the ClipX has a internal sample rate of 19.2 kilosamples per second. What that means is that the ClipX, it has the ability to do these onboard calculations. It can make determinations based on current values of readings. What that means is this is going to be happening at 19.2 kilohertz, right? So 19.2 thousand times a second. That's really fast. When it comes to feeding that data back to the your OPC UA server or feeding it back to your PLC, it's not going to happen that fast. The sort of the mantra of the ClipX is this idea that we want to deliver results and not readings, right? We have these smarts integrated into the amplifier. So we don't need to send data back to the PLC at a super fast rate. We don't need to send it into the cloud at a super fast rate because those decisions are being made on the device itself. This is going to, offload some of the requirements of your PLC, but it's also going to just help you make these decisions faster with more signal dynamics because you're shifting that decision onto the signal conditioner as opposed to your PLC.
Yeah, that makes a lot of sense. You don't need 19,000 copies of the same value.
Yeah, exactly. We'll now move on to talk about some of these advantages of the smart signal conditioner, some of which we've already touched on a little bit. One of the big ones is going to be this digital configuration, right? Here's a screenshot of the sort of configuration web server on the ClipX. This is something that is hosted directly on the ClipX device. No external software is needed. You can just pull up your web browser, ping the IP address, and now you have everything you need to configure the ClipX device. No potentiometers. You don't need to send an electrician in every time you need to make changes. In fact, if you have this put on something that is accessible by a public network, then you don't even necessarily need to be at the facility to make these adjustments. It can all be done wherever you're able to access the web server of the device. We do have a link down in the show notes. It's how to work with the ClipX. It's a collection of our tech notes, which describe some of the explicit applications, some of the ways to configure the ClipX for different applications. This is going to include, setting up the ClipX with different types of PLCs, how to do certain types of calculations like check weighing, things like that on the ClipX. So that is all good information. If you're looking for more of the capabilities, or if you're just getting started with the ClipX and trying to learn more about it.
Yeah, I also see you have, and I might be stealing your thunder here, but it also seems like it has the ability to have its own I/O. I see digital and analog I/O in the left menu.
Yeah, that is something that will come up in a couple of slides here, but your observation is keen there, Sean. Yeah, so one of the other advantages that something like our ClipX would offer is this device-to-device communication. The ClipX devices utilize a proprietary communication device. We call it our ClipX bus. not very creative, but I mentioned that these ClipX devices are single channel units. That being said, they can be bused together for up to 6 of them in on one segment of this bus, meaning that you can share data from one ClipX to the next in case you have a decision that's based on 2 of these. You need 2 or more physical measurement channels. One of maybe you need a force and a displacement for a press application or something. You can bus this information together and make decisions from the sort of the primary ClipX based on the status of the other ones further down. Another really explicit HBK application of this, we sell a multi-component load cell called our MCS10. This has FX, FY, FZ. Tension, compression, on all 3 primary axes. Then it also has the torques or the moments around those same axes. So MX, MY, MZ. With that device, we actually we publish a compensation matrix for each load cell independently that can eliminate the crosstalk. When you twist around the x-axis, right, you're going to be inducing some sort of force on the other axes. This crosstalk compensation matrix, this calculation can help eliminate that crosstalk. And with something like the ClipX here, you could have 6 ClipXs bust together, do that compensation right on the ClipX, and then not have to worry about doing any of that linear algebra back on your PLC or coding any of those calculations. So again, makes integration there a lot easier. There's really a whole list of calculations that the ClipX can do on the device. We've got that compensation matrix for our multi-component sensors. We've got different analysis calculations. This could be filtering, doing a moving average, triggering something based off of a rising edge, a falling edge. We've got check weighing applications. We've got more simple math, so adding, dividing. Some of these technology functions like PID control or being able to generate a signal, output it, looking at being able to do standstill detection. So, is the machine still running? The important part about these calculations is that they are available and configurable with just drop-down menus in the ClipX, right? You don't have to.
There's no special part number. This is like you get a ClipX, you get all of this, or some of these like add-ons.
No, these are all available in every version of the ClipX. So whether you have the BM40, the BM40IE, irregardless of the type of communications your ClipX has, these are all just part of the standard firmware. And again, drop-down menu, pick your calculation, enter in the fields, no programming needed, no really no time required at all. Very easy to work with. I mentioned just a few moments ago that the ClipX has the ability to take in multiple different inputs. So the ClipX supports full bridge, half bridge transducers, voltage inputs, current inputs. This is either 0 to 20, 4 to 20 milliamp inputs, potentiometer inputs. It can take in resistive thermometer devices. And the nice part about this, the ClipX, as opposed to some of our older devices like the Clip, is that all of these inputs can be made to one module. All of these can go into your BM40 module. You don't need a separate part number for strain gauge inputs. You don't need a separate part number for the voltage inputs. It's all one type of device. Now, this is great when you are trying to keep hot spares on the shelf somewhere, because it means you only have one type of spare device. You've only got one type of module to quote. When you need a replacement, you don't have to go out on the floor, check the part number. You just know that whatever type of input it is, it'll all work with the ClipX device. You alluded to it earlier, Sean, but the ClipX device does have some integrated I/O. It has two digital inputs and two digital outputs. These can be used for the limit monitoring calculations on the ClipX. You can throw a control level digital output to flip a relay, anything you might use those DIOs for, quick feedback back to your PLC, whatever you might use those for. Those are included again on every version of the ClipX. Also has peak value storage, which is something you won't really get with a traditional analog device, but since it's completely digital, you can store peak values. This is min, max, peak to peak. You can clear these remotely using those digital inputs or using the field bus interfaces.
Can you read them remotely from the field buses too?
Oh, of course, yeah. Those are those are values passed just over to the field bus as well. So
I can see every production run wanting to read in all the peak values and then wiping them. So every time you run a production run, if you're not doing continuous process, but in some processes maybe you do it on every 8 hours or something. If it's something you're closely watching, I could see wanting to do that and store that in my PLC or historian with the batch data or the run data.
Yeah, of course. And then one of my favorite, or what I think one of the really powerful functions of a smart signal conditioner like the ClipX is this ability to add in a linearization or a characteristic table. I like to say this helps with linear-ish sensors, right? Every time you buy a load cell, you're buying it under the presumption that there is a perfect linear relationship between the 0 point and the full scale. You might get a test certificate that has 0 load, 100% load, and even if you get a test certificate or a calibration cert that has 6, 8, 11 load steps between 0 and full scale, with something like an old school more analog signal conditioner, you really can only adjust for that 0 point and that full scale point. Something like the ClipX is going to allow you to enter up to 21 characteristic points. So if you have your calibration cert with 10, if you have a load cell, you have 10 points in compression, 10 points in tension, and then a 0 point. You can enter all of those points into your ClipX. And now you're not looking at just this ideal linear line between 0 and full scale. You're looking at all of these smaller linear segments, which is going to greatly increase the confidence you have in your measurement. And I mean, your errors from nonlinearity are going to decrease because you can take this measurement based off of the actual characteristic of your sensor once you have it calibrated here.
Yeah, that can be super painful to do in the PLC and very memory intensive in the PLC, and something I could see if you have a sensor that you can't replace and it's not very linear and you're struggling with it, this could be a reason. That could be a reason alone just for getting one of these to do that, because again, doing the PLC code, unless you've done a lot of testing and created your own add-on instruction to do it, or function blocks to do it, it's painful. It's painful. This just makes it go away.
Yeah, excellent point there. Beginning to wrap up here. A smart signal conditioner like the ClipX from HBK, plain and simple, is going to give you a more accurate measurement. And as I mentioned, HBK is a measurement company, right? We have historically been a strain gauge whether we're creating the sensors, whether we're creating the gauges itself, whether we're creating the products to measure these strain gauges, we have been leading in this industry for the past 70 years. And what a more accurate measurement means for you is that, looking at these two graphs down here, the one labeled without here might be a demonstration with a conventional amplifier, right? You've got your tolerance band in the green in the middle, and you've got your measurement variance sort of in the red, right? And if you have more variance in that measurement, or you have less certainty in that measurement, then you've got to sort of increase the width of those bands, right? You want to make sure that statistically the parts that you are giving a go and okay certification to fall within where you need them to be. When you create a measurement chain with a more accurate amplifier, something that has significantly less uncertainty, you can have more confidence that what you're measuring, what you're seeing at your PLC is the real value, and we can start, decreasing those variance bands. Right, we have a better idea of what our measurement is, meaning that there's now less parts we have to reject. We can tighten up or broaden out those tolerance bands, knowing that when we measure something that is within our okay band, it is in fact okay for us. And this isn't just something that HBK. We stand behind this claim because each of our ClipX devices is going to come with a traceable calibration record. This is included from the factory. It's stored directly on the memory on the ClipX device, so it's always accessible. It's always tied to the amplifier in that way. The nice part about being a digital device means that if you have a digital calibration record for the sensor that is plugged into this ClipX, you can store that on the ClipX too, which makes keeping all this information straight a lot simpler, which is of course very, very important in case of a 9001 ISO 9001 audit, or in case of a recall. You having to be able to prove that this data, these instruments have a traceable calibration. And again, this is included with each ClipX. It's not an additional charge. We really do sort of stand behind the measurement capability of the ClipX. So sort of the last part of this puzzle is, how do I integrate one of these into a new system, into an existing system? We try to make it very easy to incorporate these into your systems. We are going to offer those real-time industrial Ethernet outputs on the BM40IE version. Again, remember this mantra of the ClipX: we're sending results and not readings. So the update rate on Profinet EtherCAT is going to be 4 kilohertz, with the idea that the device itself, when you're, if you're making those determinations on the device, if you're capturing those peak values, that's still happening at the 19.2 kilohertz of the internal clock of the device. Just those, the report rate out to this industrial Ethernet is going to be inherently slower than that. The Ethernet IP, just because of the nature of it, does have a slower update rate as well at 1 kilohertz. The really convenient part for me, as someone who demos this hardware, as someone who often needs to change my setup to show customers different capabilities here, the BM40IE device is capable of doing all of the industrial Ethernet outputs, your Profinet EtherCAT, Ethernet IP, Modbus TCP. You don't need a different device for each of these industrial Ethernet buses. You can just change what bus you want it to operate on from the web server, and you're good to go. You get your ESI file, or you get your ESD or your GSDML, whatever matches your bus. You generate that from the web server, put it into your system, and now you're working on a different bus. The only one that you do need a different device for is the Profibus one. That is that BM40PB. So if you need Profibus, you'll have to buy that one explicitly. But in addition to these industrial Ethernet outputs, you also have sort of these old school analog outputs too. So the ClipX does have an analog output on it. It can be configured to be either plus or minus 10 volt, plus or minus 20 milliamp. It can do 4 to 20 milliamp as well, of course. These are great if you are trying to go into if you're retrofitting these into an older system that needed these control level signals as opposed to digital communications. But they're also great for proximal monitoring, right? So maybe you need to feed into a meter because you need to be able to go and actually see what the value is of the device at the device. These analog outputs are great for feeding into just a panel meter for that level of monitoring too. But whether you're using it for the actual signal or just monitoring, these devices have a lot of flexibility for how they can end up back in your system.
Yeah, I could definitely see people wanting to put this in between maybe an existing sensor and an existing controller, and to get it on Ethernet IP or Profinet, EtherCAT, Modbus, TCP, whatever. And by having these legacy outputs, plus or minus 10 or plus or minus 20 milliamps, that's awesome because you could now, put that device in. I can also see people, the local panel meter, the proximity viewing is very important, but I also can see people using those outputs for IoT or IoT. There are a lot of situations where you do not want your field bus or your OT network connected to the cloud because you don't want to be exposed to hackers. So this gives you a nice way to have an output only, that can go to an IoT system or IoT system and give, the cloud some viewing capabilities without writing capabilities. So that is very cool. It really, like you guys just haven't sat through this. It's like you buy one device, it seems like you have access to everything, which I love about that, especially having all the, if we go back 10, 20 years, you had to buy a different device every time you wanted from most vendors, every time you wanted a different field bus. So this is excellent.
Yeah. And sort of my last slide, which is sort of really everything that I've talked about here. A great slide to review if you have any questions here, but really wraps up everything that I've said here. Gives you sort of this map of how this might actually look in your system. So of course, we're sampling at that really fast internal sampling rate, and we're either feeding data over the field bus, so the industrial Ethernet or the Profibus, and then we've got our analog output, which we might be using for a panel meter. We've got our digital I/O that we can trigger different things off of. Our standard Ethernet connection for configuration of it, or subscribing, reading out the internal buffer over that TCP/IP connection. You'll notice that if I actually turn on my laser pointer here, you'll notice that we do have this pre-built data viewer application where you can store data locally on a PC. We're feeding into OPC UA. The ClipX has an API that a .NET API that you can build your own software around it for. It's a very flexible device that can be implemented in sort of a menagerie of different ways. Whatever.
Yeah. I want to just throw in there for the audio only audience that API supports Windows, Linux, MATLAB, Delphi, National Instruments, and I don't know what the other two icons are, but for the audio only audience, if you're using MATLAB or National Instruments or Delphi, or what would what are those other two? Do you know off the top of your head?
Don't know. They may be. I think this one at least is still NI related. So whether it's
National Instruments, yeah, kind of
yeah,
does look
whether it's
like it.
LabVIEW or Diadem, I know
Mm.
some of those programs are a little more specific to a European audience.
Sure, yeah, and I mean the point is there is an API there. As far as OPC UA, I can see some instances where this would be installed and they would want to serve the information via OPC UA. So is that an additional license, or is it just plug and play that the device, do you need an additional license to enable the OPC UA feature?
No additional license required, and we actually do have we call it it's a series we call Expert Talk on the HBM website. You should be able to search for it and find it. We do have an example of uh, a process that we HBM used the ClipX to sort of modernize a heating process for the manufacturing of some of our load cells.
Okay.
We just had RTDs being fed into ClipX, and we were taking that data, sending it into an OPC UA server. So we can give you an idea of how that might look as well. That's something you can find on the HBM website. But no additional license is needed. That functionality is included with the ClipX device.
Now, let me ask you about I know I'm kind of going off on all these tangents, but I can definitely see people wanting to run that PC data viewer. And so is that a software package you have to purchase? And does it have it seems like it has the ability not only to visualize the trends of what you're getting out of your ClipX, but also to record it to your hard drive.
Yeah, so that is something that we actually distribute for free on the product page for the ClipX. It is anything that goes over the TCP/IP interface. So that standard Ethernet connection is limited to 1 kilohertz. So that's why you'll see that recorded in that box, as well as our API, being limited to the 1 kilohertz. You have the ability to plot the data, save it as a CSV file to your local PC, all included for free. The only thing you need to run this software, I believe it's Java based, so you'll need that installed. But you can download it for free, you can run it for free, and yeah, it's a tool that may be helpful when you're trying to learn more about or closely monitor, see some of these plots regarding your measurement task, right? So if you're early in still developing, trying to figure out, okay, what might I want for filtering, what might I want for making sure excitation and your scaling is all correct. That may be a really convenient tool for that type of application.
I also could see where it could be useful to use it, just for troubleshooting, right? So you have all these different outputs around the plant. You think some of them are a little weird. This is a great way. You don't have to buy a PLC and a SCADA system, and you could just put the ClipX in the panel, wire everything up, and back on your PC, run this, and get a really good idea of what's happening in the field without
Yeah.
infrastructure. I could see electricians keeping one of these on the shelf just to do that, just to run around the plant and check out different you know you know loops that are happening this that they are concerned about being you know not stable or out of range or whatnot. So it's definitely easier than carrying around a scope as well.
Yeah, so certainly so. Yeah, and again, a lot more flexible too. So
Yeah,
you're not trying to tap in and measure just the voltage output while giving excitation from a different source. Is
yeah, well, that's
could
big.
easily hook up. The ClipX here actually has you can see them in this image here. Um, it has a Phoenix Quick Connect style connector. So they are just spring-loaded clips that you depress with your screwdriver and insert the wires in. So if you are using this as a diagnostic tool at making quick connections and then undoing those connections, it is a very easy device to work with, sort of in the field as well. No soldering needed for connections or anything like that.
Excellent.
So if anyone in the audience has additional questions, a great way to get a hold of HBK, our general support group, is with our email address, support@usa.hbm.com. Don't let the email domain confuse you. Our HBM support is still that usa.hbm.com domain. We also have a technical support hotline that is manned 9 to 6 Eastern time every day of the week. That is 1-800-578-4260. That's great. You can just follow the prompts for the industrial electronics, and they will route you to somebody who can help answer some of your questions about some of the things you may have seen today. You can also feel free to send me an email at my personal email. That is nehemiah.mcintyre@hbkworld.com.
Excellent, Nehemiah. I really appreciate you coming on the show and sharing that very interesting product, these smart signal conditioners. And really appreciate you just taking the time out of your busy schedule to not only put the presentation together, but then come on the show and educate our audience about it. So thank you very much.
Of course. Thanks for having me, Sean.
Well, I hope you enjoyed that episode. I want to thank Nehemiah for coming on the show and reviewing signal conditioner technology, as well as the advanced features of their smart signal conditioners. Are very, very cool stuff. If you enjoyed this episode, please consider giving us a like and a sub. And if you'd like to learn all about my PLC, HMI, and SCADA training courses, you can check them out over at theautomationschool.com. There's a new pop-up that'll save you an extra 10% on your first course. With that said, you can always follow me at automation.locals.com. And I want to wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.